Good morning, students. Chapter 2, Units and Measurement. Yes, we have discussed numbers of dimensional formulas for different quantities. Okay, now we will see dimensional analysis. Dimensional analysis and applications of dimensional analysis. Yes, first application of dimensional analysis is checking the dimensional consistency of equation. Now, what is meaning of dimensional consistency of equations? If I have mass m1 is equal to 5 kg, mass m2 is equal to 10 kg, then yes, I can write m1 plus m2 is equal to 15 kg. Okay, but if I have m1 is equal to 5 kg and t1 is equal to 10 second, t1 is equal to 10 second, then I cannot write m1 plus t1 is equal to 15. Why? What is reason? Here I can add m1 and m2 because they have same dimensions. They have same dimensions, kg and kg. Okay. Here I cannot add m1 and t1 because they have different dimensions. Here it is kg, here it is second. So yes, you have to remember one point. K, two quantities are added or subtracted from one another if they have same dimensions. Okay, quantities are added or subtracted from another quantity if they have same dimension. If they have same dimensions. Okay, so yes, it is one important point that you have to remember. Quantities are added or subtracted from another quantity if they have same dimensions. Yes, if I am given two masses m1 and m2, then yes, I can easily add them. Okay, I can add them. But if I am given two different values m1 and t1, then I cannot add like this. Okay, their magnitude I cannot write like this. Like this. Clear? But yes, magnitude of two masses, it is 15. I can write like this. Clear about this? So yes, physical quantities, they are added or subtracted from another quantity if they have the same dimensions. Okay, and yes, such property or such simple principle is called principle of homogeneity of dimensions. Okay, such simple principle is called homogeneity principle of dimensions. Clear about this? Okay, such simple principle is called homogeneity principle of dimensions. That you have to remember. Now, how to check dimensional consistency of equations? We will see with the help of some examples. See, if yes, I have this equation, that is x is equal to x0 plus b0t plus half at square. Yes, I have this one equation. Okay, then yes, I have to check, is this equation dimensionally consistent or dimensionally correct or no? Now see, we have two sides, left hand side and right hand side. First of all, left hand side. Left hand side we have only one term, that is x. And what is x? It is position. So what is dimensional formula of position? Position means distance length, and its dimensional formula is L1. Okay, now right hand side. So see, right hand side we have total three terms, x0, b0t and half at square. I am talking about the whole term. Okay, here first x is 0. x0 means initial position, so its dimensional formula is again L1. Right hand side, another, the whole term is v0t, this whole term, okay, x0 plus v0t, so you have to consider this v0t as whole term. How to find dimensional formula of v0t? v0 initial velocity, v0 initial velocity, its dimensional formula, it is L1 t minus 1, and t, that is time, so its dimensional formula is t1. Simple. So yes, this t minus 1 t3rd, so it is only L1. Any doubt? Okay. Now next one is, it is half a p square is equal to, half, it is number, no dimension. Half is number, no dimension. A, acceleration. What is dimensional formula of acceleration? L t minus 2. Well, it is t, its dimensional formula is t, and it is square, so it is t2. So again t2 t minus 2 cut, so it is only L1. So see here we have total 4 terms, 1 on left hand side and 3 on right hand side, and dimensional formula of each and every quantity is equal. Dimensional formula of each and every quantity is equal. Okay, here dimensions of each term on left hand side and right hand side are same, and therefore it is dimensionally consistent. Clear about this? Or we can say it is dimensionally correct. It is dimensionally correct. Okay, so yes, how to find consistency of any equation? You have to find dimensional formula for each and every quantity. Okay, you have to find dimensional formula for each and every quantity. And if dimensional formula for each and every term it is same, then yes, that equation is dimensionally true. Now yes, you have to remember, if any equation is dimensionally true, then it is not right to say that that equation is true. Okay, yes, there are some limitations of dimensional analysis. That we will see later. Okay, but yes, if dimensions of each and every terms they are not consistent, equation is totally wrong. If dimensional formulas are not same, then equation is totally wrong. But if it is consistent, then it does not mean that that equation is right. Okay. Now see, we will see another example. See, for example, if we have equation u is equal to mgh. Where what is u? Yes, u is potential energy. M is mass. G is gravitational constant. It is gravitational constant, and h is height. So yes, we have to prove dimensional consistency of this equation. Okay, this equation is right or wrong dimensionally. Okay, so yes, left hand side we have u that is potential energy. Its dimensional formula is m1 L2 t minus 2. Yes, right hand side we have mgh. M that is mass, its dimensional formula is m. G, gravitational acceleration. G is gravitational acceleration. So what is dimensional formula of acceleration? Yes, dimensional formula of acceleration, dimensional formula of gravitational acceleration, it is same, and it is L t minus 2. Height, what is dimensional formula of height? Height means this length. So yes, this L. So if you simplify, you will get m1 L2 t minus 2. So yes, dimensional formula for u and mgh, they are same. dimensional formula U is equal to dimensional formula of MGH, means it is dimensionally correct. It is dimensionally correct. Clear about this? So yes, it is one equation. It is one equation, that is U is equal to MGH. X is equal to x0 plus v0t plus half a square. Clear about this? Now, if each and every term they do not have same dimensions, then obviously that equation is not consistent. That equation is not consistent. Okay, so yes, we have to write that it is dimensionally incorrect. It is dimensionally incorrect. Okay. Okay, next example is see, here it is. If I have one equation like this, okay, it is V is equal to V0 plus AT square. Then I have to check, okay, if this equation is dimensionally correct or not. Okay, so yes, left hand side we have V. V means velocity, final velocity. So its dimension is, it is L t minus 1. Right hand side, we have V0. We have V0. V0 it is initial velocity, so its dimensional formula is also L t minus 1. Right hand side, we have another term, that is AT square. A is acceleration. Its dimensional formula is L t minus 2. T square means it is T2. So T2, T raised to minus 2 third, so it is only L. So see here it is. Dimensional formula of V is equal to dimensional formula of V0, but is not equal to dimensional formula of AT square. Is not equal to dimensional formula of AT square, means it is not dimensionally correct. It is not dimensionally correct or not dimensionally valid. Clear about this? Okay, so yes, if dimensions of each and every terms they are same, then it is dimensionally correct or it is dimensionally not correct. Okay, now yes, there are some other types of question. Okay, yes, here you are given equation and you have to find consistency. Okay, you have to check consistency. Okay, it is dimensionally consistent or not. But if you are given some equation directly, yes, it is dimensionally consistent. Okay, for example, you are given x is equal to 80 plus bt square plus 60 is dimensionally consistent. Then find dimensions and units of A, B and C. Okay, here x is distance and t is time. Here x is distance and t is time. Okay, what is question? You are given one equation. Okay, that equation is dimensionally consistent. Yes, you are given. Okay, you have to find dimensions and units of A, B and C, where x is distance and t is time. Now see how to find this. This equation is dimensionally consistent. It means dimension of x is equal to dimension of AT is equal to dimension of BT square is equal to dimension of CT cube. Clear about this? If each and every term have the same dimension, then it is dimensionally consistent. Yes. So if it is already given, the equation is dimensionally consistent, means dimension of x is equal to dimension of AT is equal to dimension of BT square is equal to dimension of CT cube. Clear? Now how to find dimensions and units of A, B and C? First of all, we can compare these two terms. Yes, we can compare these two terms. Okay, see. First of all, we can compare x is equal to 80. X is equal to 80 is 80. Then how to find dimension of f? Dimension of A is equal to dimension of x upon dimension of t. X, distance, its dimensional formula it is L. T, time, its dimensional formula is T. So yes, it is L1 T minus 1. It is L1 T minus 1. Any doubt? It is L1 T minus 1. Any doubt? Okay? Yes, you have to find what is dimensional formula of A. That is L1 T minus 1. Okay? Yes, unit, how to find units? L stands for distance and T stands for time. So yes, its unit is meter per second. Its unit is meter per second. Any doubt? Now, how to find dimensions of B? Yes, I can compare x and bt square. Okay, x is equal to, here it is bt square. X is equal to, here it is bt square. So again, make B a subject. B is equal to, it is x upon t square. So yes, x means it is L. T square means it is t2. So it is L t minus 2. It is L t minus 2. And so yes, it is dimensions of B. What is its unit? L stands for meter and T means second. So it is meter second raised to minus 2. Okay. Now third one, yes, you can compare like this. Okay, x is equal to, it is CT cube. X is equal to, it is CT cube. Okay. So therefore, what is dimension of C? Dimension of C is equal to dimension of x upon dimension of T, its cube. Okay, so it is L, here it is T3, so it is L T minus 3. And what is its unit? Yes, its unit is, L stands for distance, its unit is meter, T stands for time, its unit is second, so it is ms raised to minus 3. Clear about this? So yes, if you are given any equation dimensionally consistent, then how to find units and dimensions of given constants. How to find dimensions of given constant. Clear about this? So yes, there are two types of question based on dimensional consistency. First of all, you have to find if this equation is right or wrong. Okay, and then you have to find dimensions of another quantities. Okay. Now we will see one another example. See, here it is. For example, if I have one equation like this, P is equal to rho GH. P is equal to rho GH. P is pressure. Rho is density. G is gravitational acceleration. And H is height. So yes, you have to check its dimensional consistency. It is dimensionally consistent or not. Okay, so yes, these are as your homework and you have to write its answer in comment box. Next one is if F is equal to AX plus BX square. If F is equal to AX plus BX square is dimensionally consistent, is dimensionally correct. Okay, then find dimensions of A and B. Then find dimensions of A and B, where F is force and X is distance and X is distance. So yes, these two questions you have to solve. And yes, you have to write their answer in comment box. Clear about this? So yes, in dimensional analysis, it is first application to check dimensional consistency of equation. Okay, if each and every term have same dimensions, then it is called dimensionally correct. Otherwise, it is not dimensionally correct. And if it is dimensionally correct, we can write like this. We can write like this. Clear about this? So yes, for today, this is it.